Hello and welcome to Basin Academy. I'm Kevin Hunter. This month's safety training will cover several key areas of safety concern, including lockout, tagout, electrical GFCI and assured grounding, confined space PCRS, and concludes with ladders and scaffolding. There are several places throughout this training where I will inject my own work and life experiences into the OSHA suggested content, and I hope you enjoy the additional commentary. Also, I'd like to remind you that since this is a pre-recorded video, you can stop, start, and replay any segment you want for greater learning and comprehension. Finally, I would invite you to pause the training temporarily in the middle, where I will designate a break for either a restroom or refreshment break, or both, and I promise to clearly state it when I reach that point. Again, I'm Kevin Hunter, and I am honored to be your instructor and offer you this safety training from Basin Academy this month. Let's get started with the first section on LOTO, or lockout tagout, and the importance of using these procedures correctly in the workplace. Following each slide in this presentation, I will provide a supplemental note or fact from the lockout tagout safety training presentation. Please use these as talking points, discussion prompts, or additional facts to reinforce key safety training concepts. Despite decades of regulatory emphasis, lockout tagout LOTO violations consistently rank among OSHA's top 10 most cited standards year after year. More than 10% of OSHA citations in manufacturing relate to LOTO failures, and worse, LOTO violations are among the top causes of fatal accidents involving machinery. So why does it keep happening? Some common reasons LOTO fails. Number one, lack of specific procedures. Many facilities have generic or outdated LOTO procedures that don't cover each unique piece of equipment. This leads to improper isolation of missed energy sources. Number two, complacency or rushing. Workers on familiar tasks may assume safety and skip steps, especially when under production pressure. A quick fix mindset often leads to tragedy. Third, there can be a problem with inadequate training. Employees might be trained once during onboarding but never refreshed. Many don't know the difference between authorized and affected roles. And number four, incorrect or incomplete lockout. Only shutting off power isn't enough. Stored energy like hydraulic, pneumatic, and gravity is often forgotten or improperly released. And number five, poor communication in group lockouts. When multiple workers are involved, locks may be removed too early if not coordinated properly. Failure to use group lockouts or HASP leads to dangerous assumptions. Number six, over-reliance on tagout alone. Some facilities still use tags without locks, especially in older or informal systems. Tags alone don't physically prevent operation and offer minimal protection. And number seven, improper removal of locks. Removing a lock without verifying the worker's location or authority can result in deadly equipment restarts. Some real-world insight for instructors. Share OSHA case reports or headlines from your region. Ask, have you ever seen anyone shortcut a lockout to save time? Encourage honest discussion and reinforce the idea. If it isn't locked out, and it clearly should be, it isn't safe, no matter how routine the job might feel to you. Reference covered in today's training, OSHA CFR 29-1910.147, a written lockout tagout plan. A written lockout tagout plan is not just a compliance requirement, it's the foundation of a facility's energy control system. According to data from OSHA and industry best practices, organizations that develop, implement, and reinforce a written plan see up to 70% fewer LOTO-related injuries compared to those without one or with only informal procedures. Here's why a written plan matters. It standardizes expectations. Without a written plan, every technician might do things differently, even on the same equipment. A clear document eliminates tribal knowledge and replaces it with repeatable, auditable procedures. Number two, it identifies all energy sources. Good plans include specific instructions for isolating all types of hazardous energy, electrical, hydraulic, pneumatic, gravitational, thermal, chemical, for each machine. Third, it outlines clear responsibilities. It defines roles, authorized, affected, and other employees, and details what each group can and cannot do. Fourth, it serves as a legal and training document. During audits or incident investigations, your written plan is your first line of defense. It also provides structure for refresher training and onboarding new hires. And fifth, it supports procedural discipline. Workers are more likely to follow steps when there's a checklist or posted instruction. A written plan builds consistency and accountability. Let's talk about some common mistakes with written plans. The plan could be outdated, not reviewed annually or after equipment changes. It's too generic, doesn't cover individual machines or multi-energy systems. Unclear language or poor formatting. Stored in a binder nobody can find, not posted or easily accessible. Employees are completely unaware of it or haven't been trained on it at all. Some objectives of this training: introduce the requirements of the Lockout Tagout standard, understand types of hazardous energy, demonstrate understanding of Lockout Tagout devices, understand the requirements for LOTO procedures, understand the company Lockout Tagout program. The purpose of Lockout Tagout is to protect employees from exposure to uncontrolled hazardous energy. This is accomplished by the use of locks and tags to protect employees like the one seen here to the right. Missing a lock can equal fatal consequences. One missing lock on a multi-person job can mean injury or death. Everyone has a responsibility to verify their lock is in place. Lockout Tagout standard requirements. Referencing 29 CFR 1910.147 requires that employers develop a written plan for dealing with the isolation of hazardous energy from machines and equipment where unexpected startup could occur or the release of stored energy could injure employees. Employers must provide energy isolation devices to employees, provide proper lockout tags, provide lockout tagout procedures, provide training for authorized, affected, and other employees. A common and dangerous mistake many employers make is failing to clearly differentiate training for authorized versus affected employees in their Lockout Tagout program. This misunderstanding has led to thousands of dollars in OSHA fines and even serious injuries when unqualified employees attempted tasks they weren't trained for. Who needs the training? Well, authorized employees for sure. These are the workers who perform service or maintenance on equipment, physically lock out and tag out machines, and verify zero energy and perform repairs. Their training must include how to recognize hazardous energy, how to isolate and control that energy, step-by-step lockout tagout procedures, use of specific devices, test equipment, and personal locks. And then there's affected workers. These are workers who operate or work around the machinery, don't lock anything out, but could be injured if a machine starts unexpectedly. Their training must include how to recognize when a LOTO is in place, instructions to never remove someone else's lock or tag, and what to do if equipment isn't working or appears unsafe. Some common training mistakes that lead to OSHA citations. Everyone receives the same generic training regardless of their role. That's bad. Affected workers are not trained at all because they don't perform lockouts. No proof of competency. Employees aren't tested or documented as trained. Number 4, no refresher training after incidents, changes in equipment, or policy updates. And 5th, contractors are not trained to the same standards as employees. Exception to the Lockout Tagout rule. LOTO is not required when hazardous energy does not exist, when activities are performed during routine production processes, when work on cord-controlled devices where the technician has direct control of the cord, and in hot tap operations where shutdown is not possible. Special procedures must be used in this case. Some misuse of the exceptions. The routine production exception is often misunderstood. It is not a loophole. Using it improperly can be legally and physically dangerous. Here's some types of hazardous energy. Upper left is electrical, stored mechanical energy like hydraulics in a truck, moving machinery, steam, springs, gravity, and pressurized fluids. What other sources of hazardous energy are present in your workplace? Think about it. Stored hydraulic or pneumatic energy often gets overlooked, yet it's responsible for many crush injuries and amputations. Here's why it's such a big problem. Number 1, stored energy can remain after shutdown. Just because a machine is turned off or unplugged doesn't mean it's safe. Hydraulic systems can retain high-pressure fluid in cylinders or lines. Pneumatic systems can hold compressed air that's still ready to actuate a mechanism unexpectedly. Number 2, uncontrolled release equals instant energy. If a valve, hose, or piston is released without proper depressurization, hydraulic rams can suddenly drop or extend. Pneumatic actuators can move violently. Pressurized parts can rupture or blow off. Injuries include crushing, dismemberment, blunt force trauma, and eye or face injuries with ejected components. And number 3, stored energy is very easy to miss. Workers often believe that shutting off power is enough. Unless energy is bled off, blocked, and verified to be zero, the system is still dangerous. A real-life example here involved a press brake accident. A maintenance worker in Ohio was called to adjust a hydraulic press brake that had been shut down for cleaning. Power was off, but the hydraulic lines still held pressure, and often they do. While checking the ram mechanism, he leaned in and the ram suddenly dropped, driven by residual hydraulic pressure. The result, his hand was crushed, and he ultimately lost several fingers. OSHA's investigation revealed lockout procedures were not followed, hydraulic pressure was not bled from the system, no visual or gauge-based verification was performed. A fine was issued for over $75,000. Was this preventable? Absolutely, if stored energy had been properly released. Some types of equipment that may require lockout, tagout: accumulators, saws, conveyors, pumps, production equipment, fluid systems, and motors. What equipment in your workplace requires lockout, tagout? Have employees complete a quick walkthrough of your facility and identify which machines need LOTO. I recommend listing them on a shared board. One of the fundamental keys to keeping each employee safe is that each employee will apply their own lock and tag to the equipment being locked out. The lock that they apply will only have one key, and it will be in their possession. The energy cannot be released accidentally or purposely until all locks have been removed. This ensures that all employees are out of danger before energy is applied. Each employee must use their own lock, no shared locks. This ensures everyone has full control over their own safety. In proper lockout tagout, the rule that each employee must apply their own personal lock isn't just a formality, it's a life or death safeguard. This rule ensures that no machine can be re-energized until each individual worker has removed their own lock, confirming they are clear of danger. So why does this rule exist? Well, number 1, accountability equals safety. If someone else controls your lock, you're trusting your life to their judgment. A personal lock ensures that only you decide when you're safe. Number 2, it prevents miscommunication. In multi-person jobs, confusion can arise. Well, I thought everyone was done, others might say. A personal lock removes assumptions and encourages clear visual proof that someone is still working. Number 3, it eliminates rushed decisions. Supervisors or coworkers can't help you out by removing your lock to get things moving. The rule enforces a pause. I can't remove it until you say you're safe. A real-world tragedy. In one OSHA-reported case, a maintenance worker was crushed inside a machine because another worker removed a shared lock, thinking the task was complete. If the victim had used their own lock, the machine could not have been restarted. Some lockout, tagout, isolation devices. There are many different types of isolation devices: locks, valve covers, chains, a multi-lock hasp, blocks, ball valve covers, piping blanks. Some of these examples are pictured right here. What lockout, tagout devices are in use in your facility? Bring physical examples of LOTO devices into class. Let participants handle and practice placing them on mock equipment. Let me explain why this is so important to do. Number 1, it bridges the gap between theory and practice. Watching a PowerPoint or reading a manual doesn't build real confidence. Hands-on use helps participants truly understand how the devices work, not just what they look like. Number 2, it eliminates guesswork in real-life situations. Workers need to know which device fits which type of energy source, how to secure a circuit breaker, plug, valve, or hasp, how to verify that a lockout is secure. Practicing this reduces hesitation or error when they're doing it for real. And third, reveals skill gaps that you can fix immediately. Instructors can observe if someone fails to apply a lock correctly, struggles with valve lockout caps, doesn't understand tag placement. Catching these issues in a training setting is much safer than learning the hard way in the field. Some real-world insight. During a refinery training session, workers were shown a variety of valve lockouts. One tech, confident from years on the job, realized that he'd been using the wrong clamp for a pressure gate valve, allowing potential bypass. After handling the correct device, he said, "I've locked out 100 of these, but I didn't know I was doing it wrong until just today." Lockout, tagout device requirements. They must be durable. Locks and tags must be tough enough to withstand the environment they are placed in. They must be standardized. The company needs to use the same equipment across the business. They should be substantial. The equipment must be large enough to be recognizable. And then, of course, identifiable. The equipment must be recognized by employees. Poorly printed or damaged tags are common. Always use UV, oil, and tear-resistant tags to avoid confusion or improper removal. Lockout, tagout, affected employees. Affected employees are employees that operate the equipment, infrequently adjust LOTO equipment, work in the area of equipment that requires lockout, tagout. Affected employees can be nearly everyone in a facility. Affected employees must be trained in and have the ability to recognize LOTO requirements. Almost all employees in a facility can be affected employees. If you're near the machine, you'll need to understand lockout, tagout. Affected employee responsibilities. It is the responsibility of the affected employee to leave lockout, tagout devices undisturbed, notify proper personnel when equipment needs maintenance or adjustment, check that equipment operates safely after lockout, tagout, follow procedures and safety rules when operating equipment. Ask yourself, would your affected employees recognize a LOTO violation and know what to do? Create a response plan if they don't. Lockout, tagout, authorized employees. Authorized employees are employees who maintain equipment, perform maintenance on equipment, perform detailed inspections of equipment. It is critical that authorized employees are fully trained in LOTO and have a strong understanding of the LOTO procedures that are specific to their equipment. Authorized employees carry the full responsibility of isolating and confirming. One shortcut could be fatal for someone else. Some authorized employee responsibilities. Place a danger tag on locked out equipment. Inform affected employees of the lockout, tagout operation. Ensure that all energy sources are isolated. Test the equipment to verify energy is dissipated. Repair equipment as needed. Remove LOTO devices when completed and verify the problem has been resolved. Verifying zero energy isn't optional. It's required. Always test after lockout and before starting work again. Lockout, tagout procedures. 6 basic steps. Notify employees. Shut down equipment. Isolate energy. Attach lockout device. Release stored energy. Verify lockout. Service and maintenance. Specific lockout, tagout procedures are required for each piece of equipment that requires lockout, tagout. Where are these procedures located in your facility? After training, walk employees to a real machine and do a full LOTO together, from notification to verification. Group lockout, tagout. What do you do when more than one person will be working on a locked out piece of equipment? Each person must hang their own lock on the device. This can be accomplished by using a multi-lock hasp and group lock boxes. Use a group lockbox or multi-hasp properly. Every worker must have their own lock, even on team jobs. Using a proper tagout system. Tags cannot be used as a substitute for locks. They can only be used alone if there is no other way to positively control the hazardous energy. They don't provide the same level of protection as lockout devices do. They can only be removed with authorization of the authorized person who hung the tag. They must be legible, securely attached, and resistant to degradation, and looking a lot like this tag we see here. Danger, do not operate. While tags are warnings, they are not locks. If a lock isn't physically preventing operation, the energy is still potentially hazardous. Why tagout alone is dangerous? Tags are only warnings, not barriers. A tag is simply a visual notice that says, do not operate. It doesn't physically stop anyone from flipping a switch, turning a valve, plugging in a cord. If someone ignores or doesn't see the tag, there's nothing to stop them. Cases of forcible removal of a LOTO device. Need for lock and tag removal is identified to the person's supervisor. Attempt to contact the owner is documented on the abandoned lock removal form. An evaluation of the entire system must be made to ensure that an injury cannot occur before the lock is removed. Names are documented on the form. Bolt cutters or other removal devices are acquired. Supervisor or designee removes the lock. Names are documented on the form. Always document abandoned locks. Supervisors should only remove locks with full verification. Skipping steps can endanger lives. A written lockout tagout standard. Every business is required to have a written lockout tagout program. This program describes the lockout tagout program at your facility. Where is the lockout tagout standard stored at your facility? To the right here is a sample lockout tagout written program. Make sure you print and post your written LOTO program in multiple shop areas. Accessibility equals accountability. Some final questions. What step in lockout tagout is most often skipped or rushed? Use answers to guide future refreshers. Thank you for your attention on this section covering LOTO, lockout tagout. We'll move on now to an equally important subject that has some crossover to the LOTO training we just went through. Next up on our training agenda is electrical GFCI and assured grounding. After all, as I'm sure you'd agree, there will always be reasons to lock out faulty electrical connections or broken down electrical equipment. After this section, I will offer you that promised opportunity for a short bathroom or refreshments break. Use it if you wish. This training applies to all personnel who use electrical tools in the workplace because the risk of electrical shock or arc flash injury exists wherever power tools are present, regardless of job title or department. Whether it's a construction worker using a rotary hammer drill, a maintenance technician operating a portable grinder, or a warehouse associate plugging in a floor scrubber, the moment electricity is involved, a hazard is involved too. For example, a 34-year-old HVAC technician suffered a severe shock while using a portable vacuum pump to service a rooftop unit. The outlet he used was protected by a GFCI, but the unit had failed without anyone noticing. Because he had no training on testing GFCI function before use, he unknowingly plugged into a dead outlet and completed the circuit with his body. When he touched the grounded frame of the unit, he did survive, but the injury left him with lasting nerve damage. In another incident, a custodial worker using a commercial buffer to polish floors at night. A floor buffer seems harmless enough, right? But the extension cord powering the buffer was frayed where it entered the machine, and the moisture from the floor cleaning increased the conductivity of the environment. Without a functioning GFCI, the worker received a life-threatening jolt when he stepped on a wet spot and touched the handle. This was later traced back to a GFCI that had tripped and was never reset or tested. These examples reinforce that GFCI knowledge and electrical safety practices are not just for electricians. Any employee who plugs in or operates powered equipment must understand how to identify hazards, verify GFCI functionality, and respond appropriately in case of equipment failure. A single skip step, like not testing a GFCI, can result in permanent injury or even death, even for seasoned workers. That's why this training is essential for everyone. Overload hazards, check out this picture to the right. If too many devices are plugged into a circuit, the circuit may heat the wires to a high temperature, which may cause fire. If the insulation melts, arcing may occur and may cause a fire, even inside of a wall. This is what circuit breakers are designed to protect against. Some frequency and trends. According to the National Fire Protection Association, NFPA, electrical failures and malfunctions, many of which stem from overloaded circuits, account for approximately 13% of all structural fires in industrial and manufacturing settings. The Occupational Safety and Health Administration, OSHA, routinely cites electrical overloads as a contributing factor in workplace injuries, including fires, equipment damage, and arc flash incidents. Facilities with older wiring or high tool turnover, example construction, fabrication shops, report overload issues on a weekly to monthly basis, particularly during peak operation hours or shift changes when multiple tools may be used on the same circuit. Here's why this happens. Common reasons overloads occur include too many tools plugged into one circuit, especially with extension cords or power strips, faulty breakers that fail to trip when the circuit is overwhelmed, improperly sized equipment or wiring, such as using a 15-amp tool on a circuit only designed for 10 amps, worn insulation or damaged tools that allow excess current draw without visible signs. A real-world example, in 2021, a machine operator at a Midwest food processing plant suffered burns to both hands when a motor overheated due to an unnoticed overload. The protective barrier had been bypassed months earlier by a contractor. When the motor failed, it ignited insulation inside the panel. Investigation revealed that the overload condition had existed intermittently for weeks. The bottom line, while overload hazards aren't always as dramatic as shocks or arc flash, they often build silently and result in hidden equipment damage, fire risk, unexpected downtime. That's why identifying load ratings, testing barriers, and using ground fault circuit interrupters, GFCIs, in high-risk areas is essential, not just for compliance, but for life safety. Ground fault circuit interrupter, a GFCI, protects from dangerous shock, detects any nominal difference within the electrical circuit leakage known as ground fault. If a ground fault is detected, the GFCI should shut off electricity flow in 1/40th of a second. This is different than a breaker. A breaker breaks the connection if too many amps are drawn from the system. A GFCI interrupts the circuit if voltage is lost due to conductive material drawing voltage. GFCI use. Various types of GFCI. It can be integrated into the breaker system or be a single outlet. Ensure any tools or equipment that could have a potential loss in voltage connected to a GFCI outlet or integrated circuit breaker. In humid conditions, where cords are run through water or around metal, and if there is a possibility for cords to be damaged by vehicles, friction, etc. The various types of GFCI can be integrated into the breaker system as mentioned in the power panel or be a single outlet. Ensure any tools or equipment that could have a potential loss in voltage are connected to a GFCI outlet or integrated circuit breaker. Let's take a look at this illustration of types of GFCI at use in the workplace today. As pictured here on the left is a wall outlet GFCI circuit. Then there's a circuit breaker which is in the panel, a portable GFCI, and an inline GFCI. Static electricity. Static electricity can cause fires in areas with flammable vapors, fumes, and flammable dust. Use caution in these areas. Monitor area for lower exposure level. Never assume that it's safe. Static electricity is the buildup of electrical charge on a surface, usually caused by friction between two materials. When two different surfaces rub together, like your clothes against the seat or your hand sliding across plastic, electrons transfer from one to the other, creating a charge imbalance. You've recognized this if you've ever touched something and got a shock in your fingertips. If that static discharge, tiny spark, occurs in a vapor-rich area, such as near a gas tank during refueling, it could ignite the air-fuel mixture, leading to fire or explosion. How do we conduct static? We conduct static through our clothing, especially synthetic fabrics like fleece or nylon, shoes, rubbing against car mats or carpet, and then just getting in and out of a vehicle mid-fueling. And then, of course, touching metal surfaces without grounding ourselves. When you slide off the seat, static can build up on your body. If you then touch the fuel nozzle or the car's metal body without first discharging that static, the spark can ignite gasoline vapors. Some real-world examples: The Petroleum Equipment Institute has documented over 150 fires at gas pumps linked to static discharge, many caused by re-entering the car during fueling and then touching the nozzle. In one case, a woman in Oklahoma suffered burns to her hand and torso after returning to her car, building up some static and igniting fumes when she touched the gas cap. One common question is cell phone use a risk while fueling? This is a myth that cell phones can ignite gasoline. It's been widely debunked. There's no confirmed case of a cell phone causing a fire at the pump. However, cell phone use is involved, and it's discouraged not because of the risk directly, but because it distracts you from safe fueling procedures. It may cause you to re-enter the car, build static, play around with your phone, and then discharge it unknowingly. Some suggestions for what you should do while fueling. Do not re-enter your vehicle while fueling, especially in cold, dry weather when static is common. If you must get back in, touch a metal part of the car away from the nozzle before handling the pump again to safely discharge static. Avoid using your cell phones, not because of the risk directly, but so you stay focused and avoid behavior that leads to static buildup. Discharge static by touching the metal pump handle before fueling. If you're wearing synthetic clothing, be extra cautious. Cotton is less likely to build up static. This illustration shows some way to avoid static discharge while fueling. Do not re-enter the vehicle while fueling. Make sure you touch metal before refueling. Avoid using cell phones. Discharge static before touching the nozzle. The bottom line, static electricity may seem minor, but in fueling environments, it can be very deadly. By staying grounded, staying outside the car during fueling, and handling the nozzle with care, you reduce the risk of fire or explosion dramatically. Some grounding hazards. Some of the most frequently cited OSHA standards. All metal parts of electrical systems that we touch, like switch plates, etc., should be at 0 volts relative to the ground. If you come in contact with an improperly grounded electrical component, you will be shocked, figuratively and literally. Avoiding a grounding hazard is critical when working with electrical systems or tools, especially in industrial, construction, or maintenance settings. A grounding hazard occurs when electrical current follows an unintended path to ground, which can lead to shock, electrocution, fires, or equipment damage. Here's a detailed explanation of what causes grounding hazards and how to avoid them effectively. So first, what is a grounding hazard? Grounding is the process of creating a low-resistance path for electricity to safely return to Earth. A grounding hazard occurs when the intended grounding path is broken, damaged, or missing. A tool or appliance has a short circuit or fault. A person becomes the path to ground. An example, gets shocked. Grounding equipment is bypassed or not used at all. Some common causes of grounding hazards: using 3-prong tools in 2-prong outlets, no equipment grounding available there; removing the grounding pin from a plug to make it fit a non-grounded outlet; damaged or corroded ground wires and extension cords or tools; faulty GFCI outlets or breakers; plugging tools into unverified temporary power sources; poor grounding or metal structures, scaffolding, or portable generators. Ways to avoid grounding hazards: always use grounded equipment. Use tools and extension cords that have 3-prong plugs. Never break off or bypass the ground pin. Ensure metal enclosures and panels are properly bonded and grounded. And second, inspect equipment regularly. Check cords and plugs for frayed wires, missing ground pins, or heat damage. Use multimeters or continuity testers to verify ground paths before energizing the circuits. Verify proper bonding of metal parts, for example, ladders, frames, etc., in wet or conductive areas. Third, use GFCIs on all temporary power sources. GFCIs protect even when grounding is imperfect by cutting power during leakage. Test GFCI circuits before each use using the built-in test and reset buttons. In damp or outdoor conditions, this is not optional, it is essential. Number 4, ground portable generators correctly. If supplying power to tools or generators, the generator frame must be grounded. Follow OSHA or NFPA 70E grounding requirements for generator-fed systems. Number 5, avoid being the ground path yourself. Wear non-conductive boots and gloves. Avoid working in wet areas or with wet hands. Don't touch grounded metal and live wires at the same time. Some tips for your teams: if you're unsure whether a circuit is grounded, treat it like it's not and assume touching it could complete the circuit through your own body. Overhead power lines present an extraordinary threat. Overhead power lines are not typically insulated. Power line workers have special training and PPE in order to work safely around them. Never use a metal ladder around power lines, fiberglass ladders only, and maintain a safe distance. Electricity can easily jump off of these wires to your body. Beware of the power line hazards when working with ladders and scaffolding. Follow the limits of approach when working near overhead power lines. For voltages of 50,000, keep all objects a minimum of 10 feet away. The grounding path. The path to ground from circuits, equipment, and enclosures must be permanent and continuous. OSHA violation shown here is an extension cord with a missing grounding prong. Don't ever use a cord in this condition. Assured grounding program. An assured grounding program has a qualified electrician to install and maintain the grounding system on a building or equipment. A good grounding system will give electricity a safe path to travel if there is a failure in the equipment's electrical system. You just want to make sure that you are never that grounding path. 3-wire grounding systems. A 3-wire grounding system is the most effective way to protect people and equipment in the case of failure. It gives electricity a distinct path to take to get to the ground. The bottom round plug is the ground wire. Never cut or remove the ground prong for the convenience of plugging into a standard 2-prong outlet. This type of prong is found on double insulated tools. Double insulated tools are wrapped in 2 layers of non-conductive materials. These are tools that only have 2 prongs on the cord. The dual insulation makes it so electricity cannot reach the user. Double insulated tools must be rated by a nationally recognized testing laboratory. Double insulated tools. Double insulated tools will have a symbol of a box inside of a box. They do require frequent inspection. This ensures that any loose wires or connections inside the tool do not contact the outer housing that contact skin, water, etc. Handheld electrical tools. These tools pose a special electrical hazard because they make continuous good contact with the hand. All handheld electrical tools must have a 3-prong cord with ground and be plugged into grounded receptacle, be double insulated, or be powered by a low voltage isolation transformer. Cabinets, boxes, and fittings. These 2 illustrations here are examples of disgusting junctions of electrical wiring. Junction boxes, pull boxes, and fittings must have approved covers. Unused openings in cabinets, boxes, and fittings must be closed. No missing knockouts. Should be kept clean and in good condition, unlike these 2 pictures here. Everybody is familiar with flexible cords. They should only be in continuous use for a maximum of 90 days. They cannot be used in place of fixed wiring methods. They are vulnerable to aging and physical damage. This example here where there's a nick in the insulation of the extension cord, this is a very common incident in power cords used throughout industry. Flexible cords. Permissible use of flexible cord in a permanent manner only in the following ways. A lighting fixture suspended from the ceiling like a pendant. Portable lamps, tools, or appliances like a refrigerator or a washer or dryer. To facilitate interchange for stationary equipment. Flexible cords cannot be used as a substitute for fixed wiring. It cannot be run through the walls, ceilings, floors, doors, or windows. Cannot be concealed behind or attached to building surfaces. Check out the meltdown on this plug. Electrical hazard, some red flags, tripped circuit breakers, blown fuses, warm tools, wires, codes, connections, or junction boxes, tripped GFCI outlets, worn, frayed, or scorched or blackened insulation around a wire or connection. You ever see a connector that looks like this? Definitely do not use it. The bottom line here is never reset a breaker repeatedly without investigating the cause. You could be ignoring a developing fire hazard. Blown fuses, like breakers, blown fuses when too much current flows through. Frequent fuse replacement suggests improper rated wiring, defective tools or appliances, overloaded circuits that haven't been upgraded. If you have warm tools, wires, or boxes, warmth or heat at an electrical connection is a warning that resistance is building up, possibly due to loose connections. Current is too high for the wire size. Insulation is beginning to break down. This heat can eventually ignite surrounding materials, so always be aware of this. Tripped GFCI outlets. Ground fault circuit interrupters, GFCIs, trip when they detect current leakage, often caused by damaged cords, moisture intrusion, and worn insulation. Frequent GFCI trips should never be ignored. They could signal shock risks. Worn, frayed, or scorched insulation. Visible damage to insulation is among the most obvious and ignored signs of electrical hazard. This includes blackened or melted wire jackets, cracked rubber or plastic coatings, bare wires exposed to air or touch. These wires can arc, shock someone, or ignite nearby materials without warning. In summary, electrical systems often give subtle warning signs before a serious incident occurs, but only if we know what to look for. Tripped breakers, blown fuses, heat at connectors, tripping GFCIs, and visible wire damage all signal underlying faults that can lead to shock, electrocution, or fire. These are not minor inconveniences. They're red flags that demand immediate investigation. You should always stop when these things happen. Recognizing and responding to these early signs is one of the simplest, most effective ways to prevent life-altering accidents in the workplace. Because, let's be honest, if your toolbox starts glowing or humming, it's probably not trying to become a superhero. Again, thank you for your attention through the first section on Lockout, Tagout, and now also this second section on electrical GFCI and assured grounding. As promised at this point, I am offering you the opportunity to keep your focus sharp by taking a short pause for a restroom or refreshments break. Please take advantage of it if you wish. Good to see you back. Next up on our training agenda is Confined Space. Confined Space, PCRS, safety training is absolutely critical because even a single mistake in these high-risk environments can lead to fatal consequences in seconds, and we want every one of you to return home safely to your family and friends. First of all, what is a confined space? A space that is large enough and configured in a way that an employee can enter bodily and perform work, has limited or restricted means of entry or exit, is not designed for continuous human occupancy. There are several confined space dangers, both with an industry and public impact. Some workplace confined space statistics in the U.S. Census of Fatal Occupational Injuries, that's CFOI data, shows roughly 1,030 workers died in confined spaces in the U.S. between 2011 and 2018. That's an average of 129 deaths per year. According to the National Institute for Occupational Safety and Health, NIOSH, 60% of confined space fatalities occur among would-be rescuers, co-workers, or supervisors trying to help without proper training or equipment. So definitely don't go help if you're not properly trained. In a confined space fatality, often 2 to 3 people die. The original entrant, a co-worker who tried to rescue them, and sometimes a third. The leading cause of death in confined spaces include toxic gases like hydrogen sulfide or carbon monoxide, and engulfment by grain, sand, or water. On the farm, there's a hidden danger. According to the U.S. Department of Agriculture and Grain Handling Safety Coalition, 1 in 5 grain bin entrapments is fatal. It takes less than 20 seconds to become completely engulfed in flowing grain. Most grain bin fatalities involve young workers, family members, or someone else working alone without a spotter. Manure pits, silos, and underground tanks also produce lethal gases, including methane and ammonia. At home, some do-it-yourself hazards you may not realize. Many homeowners or handymen are injured or killed each year entering septic tanks, crawl spaces, cisterns, or old wells. These spaces may lack ventilation, contain rotting organic material releasing dangerous gases, be prone to collapse or flooding. In one case reported by local EMS, a homeowner passed out and died after entering a sealed crawl space that was oxygen deprived and filled with CO2 from soil bacteria. What makes confined spaces so deadly? You often can't see or smell the danger. Rescue attempts are almost always improvised and deadly. People underestimate the risk in familiar spaces, like a farm they've worked for decades on or a crawl space at home. Atmospheric hazards can change fast. Oxygen can drop in under a minute. Some examples of confined spaces: tanks, manholes, boilers, furnaces, sewers, silos, hoppers, vaults, pipes, trenches, tunnels, ducts, bins, and pits. Permit required confined space. A permit required confined space is confined space that has one or more of the following characteristics: contains or has the potential to contain a hazardous atmosphere, contains a material that has the potential for engulfing an entrant, has an internal configuration such as an entrant could become trapped or asphyxiated, or contains any other serious safety or health hazard. And quite often around a space like this, you'll see this sign, Danger, Confined Space, Enter by Permit Only. I don't think I'd want to enter at all. Other serious hazards. Permits are required when the employer determines that other serious hazards exist. These could be extreme temperatures, mechanical and hydraulic energy, lifting problems, noise, slippery surfaces, and there could be others. There are real benefits of a confined space permit for the operator, so let's examine those. Number one, ensures hazards are identified and controlled. The permit process forces a thorough pre-entry hazard assessment, including atmospheric testing for O2, flammable gases, toxic vapors, mechanical hazards, example, augers, agitators, engulfment risks like grain, water, and sand. Result, you're not guessing. You're working with facts and verified controls, greatly increasing your odds of survival. It writes a clear written plan. The permit outlines who enters, how long, and under what conditions. Everyone on the team knows their roles, emergency procedures, when it's safe to stop or evacuate. The result prevents miscommunication and confusion, especially under pressure. And third, documents atmospheric testing. Most confined spaces need to be tested for oxygen levels, must be 19.5% to 23.5%. The LEL, lower exposure limits for flammable gases, toxins like carbon monoxide or hydrogen sulfide. The permit serves as legal and safety documentation that testing occurred before and during entry. Number 4, requires safety equipment verification. The permit ensures operators have proper PPE like harnesses, respirators, etc., have ventilation set up if needed, have rescue systems in place like tripods and winches. The result, entry isn't allowed until everything is in place. There are no shortcuts. Number 5, assigns and trains the attendant. The permit mandates that a trained attendant must be present, constantly monitoring for danger, maintaining communication, never leaving the post. The result, the entrant knows someone is watching their back 100% of the time. Number 6, legal and regulatory protection. Having a completed permit can show the company followed OSHA 1910.146 procedures, employees were trained and hazards addressed. The result, in the event of an incident or inspection, the permit protects the operator and employer from liability. Number 7, reduces panic in emergencies. Permits require pre-planned rescue procedures, reducing chaos when seconds count. Trained rescue doesn't happen ad hoc. It's practiced and it's planned. Number 8, promotes a safety culture. Following the permit system signals to all employees, we take safety seriously. Safety is part of operations, not an afterthought. The end result reduces complacency and improves morale. Employer requirements: evaluate the workplace, posting danger signs or other things equally effective, appropriate measures to ensure those spaces are not entered, establish an entry permit program. More on employer requirements. Under the entry permit program, the employer shall implement measures to prevent unauthorized entry, identify and evaluate the hazards of permit spaces, develop and implement the means, procedures, and practices necessary for safe entry, provide the appropriate equipment, evaluate permit space conditions when entry operations are conducted, provide at least one attendant outside the permit space, provide a means by which an attendant can respond to an emergency, designate the person's duties and provide training as required, develop and implement procedures for summoning rescue and emergency services. Some thoughts about signage. Obligated to inform exposed employees of the danger posed by permit spaces. Warning signs that read danger, permit required, confined space, do not enter, or other similar language would satisfy requirements for a sign. It shall appear in English and in the predominant language of non-English reading workers, like the sign we see here. The importance of confined space signage. Properly placed warning signs are a critical first line of defense in confined space safety, not just for workers, but for supervisors, contractors, and even innocent bystanders. Why signage matters? Number 1, it identifies hidden hazards. Many confined spaces look ordinary, like tanks, manholes, silos, crawl spaces. A clearly labeled danger confined space permit required before entry sign warns everyone that oxygen levels may be low, toxic gases may be present. Entry could be fatal without proper procedures. Number 2, it prevents unauthorized entry. OSHA found that many confined space fatalities involve untrained individuals entering out of curiosity or pure ignorance. Bold signage deters temporary workers or subcontractors from entering, maintenance staff unfamiliar with the area, and bystanders or passersby from entering. Number 3, triggers safe behavior. Signs serve as a visual cue for workers to check if they have a current permit, confirm gas monitoring has been done, suit up in the proper PPE. If there's no sign equals complacency. A strong sign equals pause and think. Number 4, improves emergency response. In case of an incident, a well-marked confined space helps rescue teams identify the hazard faster, prevent additional would-be rescuers from rushing in unprepared. Some best practices for signage include: use standardized language like danger, permit required, confined space, do not enter. Position signs at every possible entry point. Use durable, weather-resistant material. Include pictograms or multilingual warnings if needed. Inspect signs regularly to ensure that they're still visible and that they're not faded, damaged, or obstructed. Key personnel. First is the entry supervisor. Duties include knowing the hazards that include understanding sign and symptoms of possible exposure, understands the consequences of exposure, and modes of exposure. The entry supervisor. The employer shall ensure that all entry supervisors verify that all tests specified by the permit have been conducted correctly, all procedures and equipment specified by the permit are in place, have been inspected properly prior to allowing entry operations to commence. Duties of entry supervisors. The employer shall ensure that all entry supervisors terminate the entry and cancel the permit when a prohibited condition arises in or near the permit space, entry is completed, must verify that rescue services are available, must verify that the means for summoning rescue operations is effective. More duties of entry supervisors. Remove unauthorized individuals who enter or attempt to enter the permit space during entry operations. Determine that acceptable entry conditions are maintained throughout the duration of the entry. The attendant is an employee who remains outside the confined space and monitors the entrance, guards the space against unauthorized entry, warns the entrance of any unusual conditions, and summons the rescue personnel when they're needed. Other duties of attendants: know the hazards including understanding the signs and symptoms of exposures, understand consequences of exposures, and the modes of exposures. Must be aware of the possible behavioral effects of hazardous exposure to authorized entrance. Maintain an accurate count of authorized entrance in the permit space. Identify who is in the permit space. More duties of attendants: must remain outside the space with visual on the entrance into the permit space, unless there's an exception. Must maintain communication with all authorized entrants. Different types of communication may need to be utilized. Monitoring conditions inside and outside the space to determine if it is safe for entrants to remain in the space. Orders evacuation if a prohibited condition is detected inside or outside of the permit space. And then there's inside versus outside. Let's talk about why continuous monitoring is critical in confined space work. Safe to enter does not mean safe to stay. Many fatalities occur after a space is initially declared safe. Atmospheric conditions inside confined spaces can change in seconds, and external factors can introduce new hazards even after entry. That's why ongoing monitoring is essential. Inside the confined space, hazards can develop quickly. Number 1, atmospheric conditions can change. Oxygen can be consumed or displaced by chemical reactions like rusting and combustion, biological decay, manure, mold, organic material, leaks from surrounding equipment or containers. Gases like hydrogen sulfide, methane, and carbon monoxide can accumulate unexpectedly. Ventilation systems may fail or become obstructed. Continuous gas monitoring is needed, not just pre-entry testing. Number 2, work tasks can generate new hazards. Cutting, welding, or painting inside a confined space can generate toxic fumes, consume oxygen, create explosive vapors. Workers themselves can introduce CO2 through exhalation in small volumes over time. Outside the confined space, the world keeps moving. Environmental or job conditions may shift. Weather like rain can lead to flooding or engulfment inside tanks or pits. lowering oxygen levels in underground spaces. Vehicles or machinery nearby may leak vapors or create noise and vibration hazards. There could be contractor work nearby. Other crews using chemicals, tools, or generators can unintentionally affect the air quality or pressure inside a confined space. So what should be monitored and how often should it be monitored? Let's take a look at the types of hazards. For oxygen levels, monitoring frequency should be before entry and continuously. Tools and equipment needed: 4-gas monitor or multi-gas detector. Other hazard type: flammable vapors, a lower exposure level %. Monitoring before entry and continuously, and tools needed: combustible gas indicator. Next hazard is toxic gases like CO2, H2S, etc. Monitoring frequency before entry and continuously, specific centers or PID monitors. Next hazard, airflow and ventilation. Monitoring frequency before and during entry. Tools needed: airflow meters and smoke test. Final threat, external threats. Monitoring frequency every few minutes by the attendant, and tools needed: visual checks, situational awareness. The role of the attendant in monitoring. A trained attendant must watch the space at all times, track conditions outside that may affect the inside, communicate constantly with entrants, stop entry or call for evacuation if any condition becomes unsafe. OSHA requires this monitoring not just as a formality, but as the backbone of safe space work entry. The bottom line, without continuous monitoring, you're working blind, and that's not good. Conditions that were safe 5 minutes ago can turn deadly in seconds. The only way to know is to keep checking. More information on duties of attendants: summon rescue and other emergency services when entrants need assistance. Perform non-entry rescue if needed. Warn unauthorized entrants to stay away from the permit space. Ensure they exit immediately if in the permit space, and inform the supervisor. No other duty shall be assigned to attendants. Primary duty is to monitor and protect the authorized entrants in the space. An entrant is the employee who will physically enter the confined space to perform the work. Duties of authorized entrants: know and understand the hazards including modes of exposures, understand the signs and symptoms of exposures, understand consequences of exposure. You must know how to properly use the equipment provided to make safe entry into the permit-required confined space. Must communicate with the entrant as necessary to enable the attendant to monitor the entrant's status. Must know how to operate the equipment being utilized inside the space. Must alert the attendant whenever the entrant recognizes any warning sign or symptom of exposure. The entrant detects a prohibited condition. Exiting the space must occur when the attendant orders an evacuation. The entrant recognizes any warning signs of exposure. The entrant detects a prohibited condition. What would be a prohibited condition? The entry permit system. The entry permit system is the employer's written procedure for preparing and issuing permits for entry into and subsequent exit from permit spaces. Entry permit contents: name of the space to be entered, purpose of the entry, date and duration of entry, the authorized entrants, the authorized attendants, and the authorized supervisors. The hazards of the permit space: isolation and hazard elimination procedures, acceptable entry conditions, results of initial atmospheric testing, rescue or emergency procedures, and numbers. Communication procedures: equipment needed, other applicable information, additional permits for like hot work, lockout, tagout, etc. Permit usage system: the permit must be signed by the individual authorizing entry. The individual signing the permit must ensure all conditions required by the permit are met prior to signing the permit. When work is completed, the entry supervisor cancels the permit and returns the confined space to service. The permit must be retained for at least 1 year to facilitate the review of overall effectiveness of the employer's permit-required confined space program. Permit must be displayed at the entry portal for the duration of the confined space entry. The authorized entrants may use the posted permit to evaluate the completeness of pre-entry procedures and point out any deficiencies that they believe exist. 10 basic rules for confined space entry. Number 1, planning by qualified person. 2, training, entrance, attendants, and rescue personnel. 3rd, isolation of the space. 4, testing of atmosphere. Number 5, ventilation. 6, attendant and communication. 7, safety equipment and proper tools. 8, the entry permit. 9, periodic monitoring of atmosphere. And number 10, rescue plan and equipment. Tailgate meeting is an excellent way of communicating about some additional concerns. Should be done prior to beginning confined space operations. Conduct a tailgate meeting. Involve all parties and contractors. Answer any questions and concerns. Discuss operations. Discuss the muster points. Discuss rescue operations. Here's why the pre-entry tailgate meeting is no time for jokes or chit-chat. Before anyone steps foot into a confined space, a tailgate or toolbox meeting should take place. This meeting isn't just a formality. It's a moment where lives can be saved before the job even begins. The purpose of the tailgate meeting is to review the specific hazards of the confined space at hand, to confirm who's entering, who's the attendant, what the emergency plan is. It's to ensure that everyone is mentally locked in before entering a space where one small mistake can turn fatal. This is the time to focus, not socialize. Here's why it must be taken seriously. Distractions can kill people. If someone is half listening because they're joking around or chatting about lunch plans, they might miss a key hazard mentioned. Forget what gas is being monitored. Overlook an emergency signal. Number 2, confined spaces aren't just another job. Every confined space is unique, has different air, structure, layout, and task. Treating the pre-job meeting as routine or casual can breed complacency, which leads to tragedy far too often. Number 3, complacency spreads like a virus. If one person jokes or shrugs off the meeting, others might tend to follow. A poor safety culture starts here, and the wrong attitude can carry into the space. So let's talk about what should be discussed instead of chit-chatting. During the tailgate meeting, stay focused on the permit review, atmospheric test results, the lockout tagout confirmations, PPE requirements, the rescue plan and who's responsible, what would cancel the job today if it happened. And then set the tone as a leader. If you're running the meeting, start with intentional seriousness. Make eye contact with those present. Ask direct questions. What's our rescue plan if we lose radio contact? Keep a firm boundary. This isn't the time for side conversations. You can always joke around after the job is done and is done safely. A final reminder here, confined spaces are unforgiving environments. The tailgate meeting is the one chance to ensure everyone walks out of it alive. Let's get into some of the hazards of a confined space. Oxygen deficiency, less than 19.5%. Oxygen enrichment, over 23.5%. Think about ways to mitigate oxygen concentration hazards. Some information on composition of the atmosphere. You have your major gases, nitrogen being 78%, oxygen 20.95%. Take a look at all the various gases mentioned on this illustration. Some effects of oxygen deficiency. 19.5% is the minimum permissible oxygen level. 16 to 19% decreased ability to work strenuously, may impair coordination and induce early symptoms in people with coronary, pulmonary, or circulatory problems. 13 to 16%, respiration increases in exertion, pulse increases, impaired coordination and perception judgment. 10 to 13%, respiration further increases in rate and depth, poor judgment, and blue lips. 8 to 10%, mental failure, fainting, unconsciousness, ashen face, blue lips, nausea, and vomiting. 6 to 8%, 8 minutes, 100% fatal. 6 minutes, 50% fatal. 4 minutes, recovery with treatment. Less than 6%, coma in 1 minute, convulsions, and death. Vapor density. Oxygen levels can be lowered by gas displacement. Vapor density is a measure of how dense a gas is as compared to an equal volume of air. Vapor density greater than 1 will sink. Vapor density less than 1 will rise in air. Vapor density of air equals 1. Vapor densities, nitrogen is 1.013, hydrogen sulfide 1.19, methanol 1.11, carbon monoxide 0.97, benzene 0.730, crude oil range 0.80 to 0.94. Some flammable gases. Take a look at this flammability band. On the left is the LEL, the lower explosive limit. In the middle is where the kaboom happens, and on the right, the upper explosive limit. Fire hazards: hydrogen sulfide between 4.3% and 46%, crude oil, solvent vapors, paint vapors, residual vapors, liquids on tank, natural gas 3.8% to 17%, carbon monoxide 12.5% to 74%, propane 4.5% to 14.5%. Production of flammable atmospheres by entrance: hot work vaporizes tank coatings, spray paint, coatings, leaks from torch gases, 10% action limit for LEL. Natural production of flammable atmospheres: natural decay processes, seepage of flammable liquids underground. Previous contents weren't flammable. Intentional dumping of flammable liquids. Cleaning procedures: procedures and processes used to clean the inside of a confined space are reviewed and authorized by the qualified person. Initial cleaning is done from outside the tank if at all possible. Some chemical hazards: inerting hazards like nitrogen and oxygen displacement, chemical reactions from manufacturing process, products stored, drying paints, oxidation and reduction reactions, cleaning with acids and solvents, rusting of metal, corrosion, decomposing or fermentation. Toxicity: the degree to which a chemical or biological substance has a harmful effect on the human body. It's dependent upon the dosage and toxicity of the substance. Routes of entry: inhalation, eye and skin contact, absorption, ingestion, and injection. Immediately dangerous to life and health, IDLH. Atmosphere which present an immediate or delayed threat to life, that could cause irreversible adverse health effects, or that would interfere with an individual's ability to escape unaided from a permit space. Permissible exposure limit: this is the lower limit of hazard for a particular toxin. Any concentration less than the PEC is considered to be safe, at least for acute exposure. Any concentration greater than the PEC requires some type of preventative action prior to entry. PEL is typically a time-weighted average over 8 hours. Threshold value limit, a TVL, is equivalent NIOSH term. Engulfment or entrapment: entrapment by a liquid or finely divided solid. Hazards made worse if liquid or solid is moving. Other hazards: fall hazards, poor lighting, poor temperature control, high noise levels, clumsiness of protective equipment, hose lines, lifelines, other contractors on site. Atmospheric monitoring: test the atmosphere in this order. Check for oxygen content, at least 19.5% and less than 23.5%. Check for combustibles, less than 10% of the LEL. Check for toxic gases. Hydrogen sulfide, 10 parts per million or greater requires SAR, or any other hazardous materials as determined by the use of the space, in example, carbon monoxide. Air monitoring: must conduct atmospheric monitoring of permitted space prior to entry. Primary purpose of air monitoring is to determine whether conditions are acceptable for entry. Entry is prohibited until initial testing of the atmosphere has been performed. Person conducting the monitoring must be knowledgeable on the operation and limitation of the specific instrument being utilized. Universal monitors: atmosphere testing shall be performed prior to every entry when the space is vacant, after a 10-minute ventilation period if ventilation is necessary, at least hourly for permit-required confined spaces, more frequently if conditions or suspicions warrant it. Always test the air at various levels to be sure that the entire space is safe. Good air near the opening does not mean there is good air at the bottom. Monitor characteristics: easily operated, readable in both light and dark conditions. They're calibrated, equipped with a peak hold feature to record the highest concentration encountered, equipped with an audible and visual alarm for a present concentration, must be explosion-proof, fully charged, rugged, reliable, and dependable, remote probe available to non-entry testing. Protection from contamination. Monitor calibration. Here's an illustration on an oxygen sensor. An oxygen sensor is a electrochemical sensor, has limited shelf life. Freezing temperatures affect the sensor. Measure partial pressure of oxygen in air. Use clean atmosphere for calibration gas. Function tests with exhausted breath or bottled air containing 16 to 19% oxygen. Combustible gas sensors, Wheatstone bridge circuit. Here's a catalytic combustion diagram. NFPA 30, NFPA 1, and IFC. Flammable combustible liquid classification by flashpoint. Flashpoint, the minimum temperature at which a liquid gives off vapor within a test vessel in sufficient concentration to form an ignitable mixture with air near the surface of the liquid. Gasoline is negative 45. Flammable gases or vapors, a sensory summary, measures percent LEL and LFL, no percent total gas. Erroneous readings attained if greater than upper exposure limit, does not test for explosive dust or mist, requires a minimum of 12 to 14% oxygen, requires 0 performed in fresh air. Inferences are organic lead, halogens, silicone, phosphorus. Here's a toxic sensor illustration, a typical electrochemical toxic sensor. Cross-sensitivity. Sensor's reaction to an interfering gas. Exposing a sensor to a gas that is not the target gas can cause an undesirable response either positive or negatively. May get readings that show more of a target cause than is actually present. May move into ventilation steps when not required. May be negative. Sensor reads out negative number. Here's a sensor and gas illustration chart. Some confined space preparation. Use mechanical ventilation like fans and air horns. Ventilate at the rate of at least 4 volumes per hour. Larger spaces require more ventilation. Make sure air supply is not contaminated. Ventilation air supply must be from fresh air uncontaminated with flammables, toxins, etc. The illustration on the upper left is not recommended. On the upper right is the recommended way to ventilate. You see where the tube goes all the way down to the bottom. Here's further illustrations of ventilation. Ventilation going from negative pressure to positive pressure. Isolation. Danger, confined space, lockout, tagout procedures must be in place before entry is made. Isolate the space from all hazards. Close valves, double block and bleed or blank flange. Empty the space. Depressurize, vent and drain. Lockout, tagout equipment, electrical sources, rotating and reciprocating parts, hazardous materials, clean residue from the space. Utilizing lockout, tagout. What are hazardous energy sources? How do you block them? Bleeding lines, venting lines, other equipment in the area not involved initially but could have effects. Barricading work area to prevent unwanted entrance. One way of doing this is using a brightly colored warning tape. Check out this illustration of personal protective equipment. Personal protective equipment should have inspections, requirements, supplied air respirators, air purifying respirators, and then make sure you know how to determine what PPE is required. Here's an example of a respirator. This one is for damage control, firefighting configuration. NFPA 1981. Here's a chart illustrating various respirators available and what their color codes mean. Types of rescue equipment. Rescue ropes, webbing, and equipment. A life safety rope, maximum working load, 300 pounds for a one-person rope, 600 pounds for a two-person rope. Minimum braking, 4,500 pounds for a one-person rope, 9,000 pounds for a two-person rope. Rope strength. Under force, anything that can cause a moving object to change its shape, changes its direction of motion, and or change the speed at which it is moving. Kinetic energy is illustrated by this mathematical equation, where m is the mass weight of the object and v is the velocity speed that the object is moving. And then there's free fall. Objects accelerate at a constant 32 feet per second for every second of fall because of the force exerted by gravity. Here's an illustration of a rescue rope. Ropes versus cable, stretching for absorbing shock, 15% safety factor, a single person 3/8 or 7/16 kern mantle rope, two people, half-inch kern mantle rope. So what is kern mantle rope? Static, low-stretch rope, used for hauling, entry, and rescue. It's dynamic, high-strength ropes, used for arresting a fall, not used in most entry or rescue situations. The core, or kern, 50% and 85% of the strength. Braided sheath, the mantle, is 15 to 50% of the strength. Rope retirement. Rescue rope, 5 years old. Industrial rope, 3 years old. Rope absorbs a 5-foot fall. Penetration of sheath. Soft spots in the middle of the rope. Exposure to chemicals. Used for one rescue only. Inspected visually and by feeling rope. When in doubt, throw it out. Here's an illustration of a rescue harness. A full body harness, D-ring connection on the back. Tripods, 350-pound working load, 5,000-pound braking strength, designed to be loaded straight down. Leg safety chain should be in place. Designed for one-person load only. Should be placed on a level surface. Cable winches. Cable has 350-pound working load. Cable braking strength approximately 4,000 pounds. Winch should have fall arrestor built in. Not designed for severe shock loading. Should be backed up for hauling a life load. Types of knots: a simple figure 8 knot, figure 8 on a bite knot, figure 8 follow through, clove hitch, munter hitch, bowline, butterfly knot, and square knot. Here's an illustration of a rescue in action. Feel sorry for the guy in the middle. Types of rescue: there's self-rescue, non-entry rescue, and entry rescue. The rescue team must be trained in all other roles in confined spaces, trained additionally to perform rescue functions. 60% of victims are would-be rescuers, maybe within the operations or from an external source, and there are plenty of problems relying on 911 for rescue. In summary, confined space permit requirements, contents listed on the permit, ventilation, air monitoring, authorized entrance, attendant, supervisor, and rescue personnel trained and knowledgeable, and then rescue operations. Please discuss in a group setting any of your questions or concerns, or get in touch with Basin Safety today. A recap of a final reminder: confined spaces are unforgiving environments. Always having a tailgate meeting before you enter a confined space could be your one last chance to ensure everyone walks out alive. This concludes this critical third safety training section on confined space, PCRS. Next up on our safety training agenda is the final module for this month, ladders and scaffolding. Ladders and scaffolding are so familiar to many of us that we use them to reach high places without even thinking about it. But unfortunately, that kind of complacency is what contributes to making them so dangerous. First up is ladder safety. You see some illustrations here of types of ladders. On the left there is a portable ladder, a good heavy-duty fiberglass ladder. Then in the center is a safety angled rolling ladder that you commonly see in commercial places like Home Depot, Menards, etc. And then over to the right is an extension ladder. And I'd call your attention to the fact that that's an aluminum extension ladder and likely to have maybe a 250-pound weight limit. That's both the person climbing and anything you happen to be carrying with you too, so keep that in mind. Ladder safety. Why is this so important? Falls from ladders can cause serious bodily harm such as broken bones, puncture wounds, concussions, and possibly death. This guy in the illustration is using 2 ladders in a rather freaky situation. 300,000 people a year are treated for falls from ladders. That's a mess of ladders on the left. The picture in the middle has a questionable setup. And over on the right, I have no idea what this guy is doing leaning off this ladder, and it looks like he's near power lines, which is another huge no-no. Working at home can be just as dangerous as working in the field. Many people get hurt at their home while using ladders, which prevents them from going to work. Illustrated in this picture here on the left is a fixed ladder, ladders that are permanently attached to a structure, building, or equipment and commonly have cages around them like this one does. Portable ladders, extension ladders, and step ladders. Some things about ladder safety, step ladders. Ladders that are self-supporting, used in situations where a wall is not available to support the ladder. It consists of 2 front side rails and 2 rear side rails. Steps, spreaders, and anti-slip feet. If you look at the illustration on the right, shows the top cap and then the top step. Most ladders will have verbiage on these top steps to say this is not a step. It might instead be a place to rest your gut. Here in this picture, 2 guys on the same ladder. Absolutely terrible idea. I guarantee you they are way overweight on the ladder. It's sitting at the wrong angle too. Ladder safety, make sure the step ladder is the appropriate length for the job you are doing. Make certain the ladder is rated for the job you are doing, and that's in terms of weight rating. Be sure to have proper footing for the ladder. That's those nice rubber feet on the bottom, or the claw grip feet. Never use a ladder for anything other than its intended purpose. Never step on the top steps of a ladder. As I said earlier, the ladder should be marked. To repeat this, ladder safety, never step on the top steps of a ladder. The ladder should be marked with the highest step that you can use. If the markings are missing, tag out the ladder and replace them. Setting up a step ladder properly. Make sure the area is clean and free from anything that can cause the ladder to fall over, such as icy and slippery surfaces, or anything that could fall and hit the ladder while it is set up. Make sure the spreaders are locked before you climb the step ladder. The spreaders are the ones between the front and back legs of the ladder, and as you can see on this illustration, this guy does not have his spreaders locked. Bad idea. A little bit about extension ladders. Consists of 4 side rails, rungs or steps, a sliding mechanism to increase the height, that's where the locks are. The foot pad is a rubber pad on the bottom that's used for hard surfaces. You can also tip those up where they have a cleat, and that can be used in soil or other types of terrain. Make sure the ladder is clean and free from obstructions. Extend the ladder if needed to the proper height. Slowly lean the ladder against the building of structure. Check to make sure the feet are securely planted. Have someone hold the base as you climb if needed. Now this particular extension ladder, the angle that it's sitting at is actually a little too steep. This bottom could slip out on this ladder. And right here is an illustration that validates that point. A rule of thumb, structure height divided by 4 to 1, the amount of base should be from the structure. For example, if you have a 20-foot tall building, we should divide 20 by 4 and get 5 feet, so the base of the ladder would need to be 5 feet away from the structure or 5 feet away from the highest vertical point of the ladder, where the ladder makes contact with the wall. Make sure to account for things like roof overhangs. The division needs to take place plumb to the point of ladder contact, as I just said. Avoid too much angle as well, because this can cause the base of the ladder to slip and cause the worker to fall. I have seen this happen on construction jobs where the bottom of the ladder was set too far out from the wall and the bottom just took off. I've seen that result in broken arms because the person's arms went through the ladder rungs, or even broken legs because the legs went through the ladder rungs. The top of the extension ladder must have a 3-foot minimum overhang past the top of where it contacts the building. So if you're looking to use this extension ladder to go up on the roof, you should have 3 feet minimum over the top of the roof. This is not only safer to get off of and onto the roof that you're wanting to get onto, but it is also much safer to get back onto the ladder too. This allows the worker to safely dismount and mount the ladder, as I just pointed out. The feet of an extension ladder may have multi-use feet. The rubber base is used for hard flat surfaces, and the rubber will provide friction to avoid slippage. The spiked ends are used for dirt or grassy areas. Be sure both feet are in the appropriate position and used on the correct terrain. Straight ladders are very similar to an extension ladder, except that they are non-adjustable in height. The safety precautions for straight ladders are the same as extension ladders. Be sure that a straight ladder is the appropriate length for the job you are completing. Here's some examples in industry where ladders are in use. This ladder that is pictured on the left is the fixed ladder we talked about earlier, which does include a cage around it to increase safety. There's also the ladder that's going up on the center picture and the ladder that's over on the right. These ladders are designed for common use and typically do include a safety cage around them to prevent falls. Fixed ladders are used in areas that require frequent access to the tops of buildings or equipment, such as pumping units, tanks, treaters, and buildings. It is necessary to use fall protection when using a ladder. Fall protection is needed and often uses a rope grab style so workers can continually climb without having to disconnect and reconnect a lanyard. A double lanyard can be used as well so workers can achieve 100% tie-off at all times. Ladder safety, follow the guidelines. Always follow the recommendations from the manufacturer. Of all the signage here to the right, the one I want to call particular attention to is the one with large letter L in it. That is an easy way to be able to tell how far out the bottom of the ladder should be and what's appropriate, and most extension ladders will have an L on the side of it to give you some guidance on what the proper angle is. Ladder safety ratings, duty ratings, this is with regard to weight. 200 pounds for a Type 3 lightweight duty, 225 pounds for Type 2 medium duty, 250 pounds for Type 1 heavy duty, 300 pounds for Type 1A extra heavy duty, and 375 pounds Type 1AA extra heavy duty. Those extra heavy duty ladders are also very heavy to move around. When climbing or working from a ladder, you must face the ladder at all times. Never straddle the ladder. Stay on the climbing side, unlike this guy in the picture to the left. Do not step on the top steps like the middle picture, and use the appropriate ladder for the job, unlike this guy on the far right. If you need to lean to the side, make sure you have proper footing and don't lean far enough that you lose your balance. If you need to move the ladder to position yourself better, climb down the ladder and reposition it. You'll definitely regret it if you end up like this guy is. More about ladder safety. 3 points of contact are required at all times while climbing, descending, and working from a ladder. If 3 point of contact cannot be maintained, other means of working from height equipment may be needed, such as scaffolding, scissor lift, man lifts, or boom trucks with man baskets. Again, here an illustration on maintaining 3 point contact while climbing ladders: 2 hands and a foot or 2 feet and a hand. When working on a ladder, do hold on, keep centered, stay straight and close to the ladder, move up or down carefully. Don't lean too far, don't reach too high, or try to reposition the ladder while you're on it. I've seen guys do it, but it's a bad idea. All right, now we will move on to scaffolding safety. Scaffolding safety training. Working safely on construction scaffoldings, covered under Standard 29 CFR 1926 450 to 452. Requirements of scaffolding. Some objectives: understand the training requirements for working on scaffolding, understand the general structural requirements for scaffolding, understand the access and working requirements for scaffolding, and understand the requirements for specialty scaffolding. The importance of scaffolding safety cannot be overstated. The National Census of Fatal Occupational Injuries reports that an average of 88 fatalities a year occur from working on scaffolding. 72% of scaffolding injuries are a direct result of supports collapsing, workers slipping, or being struck by a falling object. On January 19, 2008, an entire block of scaffolding was overturned by high winds. Fortunately, only one person was injured. There are suspended scaffolds like this one from the rooftop of this building. There are supported scaffolds on the ground like the one down on the left, and then there are other types of scaffolding available on a man lift like the one in the bottom center. Some scaffolding training requirements. All employees who perform work on scaffolding must be trained by a person qualified in the subject matter. The training must include, number 1, the requirements of the OSHA scaffolding subpart. Number 2, electrical hazards, fall hazards, and falling object hazards in the area. The correct procedures for dealing with electrical hazards and for erecting, maintaining, and disassembling fall protection and other fall object protection systems. Number 4, proper use of the scaffold and proper handling of materials on the scaffold. And number 5, maximum loads and load carrying capacities of the scaffold. And never forget, that includes your own body weight and any materials or tools that you bring up there too. All employees who erect, disassemble, move, operate, repair, inspect, or maintain scaffolding must be a competent person. The training must include the requirements of the OSHA scaffolding subpart, the nature of scaffold hazards, the correct procedures for erecting, disassembling, moving, operating, inspecting, and maintaining scaffolding, design criteria, maximum load capacity, and intended use of the scaffold. Scaffolding certification. Employees need to be trained on the specific hazards and requirements of the scaffolding in their work area. After completing training, they should complete a certification specific to their work area. Here's an example of a company certification program. Scaffolding design. Scaffolding systems must be designed by a qualified person and constructed in accordance with that design. A qualified person is one who, by possession of a recognized degree, certificate, or professional standing, or who, by extensive knowledge, training, and experience, has successfully demonstrated his ability to solve or resolve problems relating to the subject matter, the work, or the project. Scaffolding capacity. Non-adjustable scaffolding must be capable of supporting its weight and at least 4 times the maximum load. Suspension ropes and connecting hardware must support its weight and at least 6 times the maximum load. Adjustable scaffolding. Stall load on hoist must not exceed 3 times the rated load. Suspension ropes and connecting hardware must support its weight and at least 6 times the max load. Pictured here to the right, the result of an overloading scaffolding. Do you know the rating of the scaffolding you are working on? If you don't, you need to get that figured out quickly. Scaffold platform construction. The space between adjacent platform units must be less than 1 inch. The space between the platform and the uprights may not exceed 9.5 inches. Platforms and walkways must be at least 18 inches wide. If this is not possible, it must be protected by guardrails and a fall arrest system. This picture above is an underneath picture, an example of bad planking. Look at all the space between the platform planking. Before we get into the text here, take a look at the picture to the right. All that heavy brick up there, an example of poor planking and unsafe loading of the scaffolding. This is a disaster waiting to happen. Each end of a platform must extend at least 6 inches over the center line of its support. They didn't do that in this picture. Platforms that are 10 feet or less cannot extend more than 12 inches over its support. Platforms that are longer than 10 feet cannot extend more than 18 inches over its support. More about scaffold platform construction. When scaffold planks are abutted to make longer platforms, each end must rest on a separate support surface. Overlapping platforms must occur over supports and must overlap for at least 12 inches unless the platforms are nailed together. Platforms that rest on a support at an angle other than a right angle must be laid first. Platforms that rest a right angle on the support must be laid second. Note that the connecting platform is not laid first, as required when it does not form a right angle. It should be on the bottom. This scaffolding also has dangerous guardrails with no mid-rail and a top rail of wire. Platform working faces. The front edge of all platforms must be no more than 14 inches from the face of the work. Faces must be greater than 14 inch if a guardrail is erected along the face side and personal fall arrest systems are used. Outrigger scaffolds must be within 3 inches of the working face. Plastering and lath operations must be within 18 inches of the working face. The platform in the picture is greater than 14 inches from the working face, as you can see. Scaffolding platform components. Wood platforms may not be covered with opaque finishes. Scaffolding components from different manufacturers cannot be mixed unless the pieces fit together without force and structural integrity is maintained. Scaffolding components made of different metals may not be used together unless authorized by a competent person. Check out all the different types of scaffolding work surfaces. If you've been on scaffolding, you've probably seen several of these. Supported scaffolds. Supported scaffolds with a height to base width ratio of more than 4:1 must be restrained from tipping by guying, tying, or bracing. First fastening device should be attached at the closed horizontal member to the 4:1 height, every 20 feet after for scaffolds less than 3 feet wide, 26 feet for ones wider than 3 feet. The top must be secured no greater than the 4:1 height from the top. Scaffolding supports. Poles, legs, frames, and uprights must bear on base plates and mud sills or other adequate foundations. The footings must be level and capable of supporting the scaffolding load. Unstable objects cannot be used as supports or working platforms. Forklifts may not be used to support scaffold platforms unless the entire platform is attached to the fork and the forklift is not being moved horizontally while it is occupied. Supports should be plumbed and braced to prevent swaying. Suspended scaffolding from above. All suspension scaffold support devices must be able to support at least 4 times the weight of the scaffold operating at the rated load of the hoist, 1.5 times the load of the scaffold at the stall capacity of the hoist, whichever is greater. Outrigger beams must be made of metal or an equivalent and be restrained to prevent movement. Securing suspension scaffolding. Before use, the scaffolding support and connections must be evaluated by a competent person who can confirm the surfaces are capable of bearing the load. Outrigger beams should be stabilized by bolts or direct connections. They should be stabilized by solid counterweights. Sand and gravel is not acceptable. Counterweights must be designed for the purpose. Outriggers not stabilized by direct connections should be secured with tiebacks. Outriggers should be perpendicular to the bearing support. Suspension scaffold support devices. All support devices such as roof hooks and clamps must be steel, wrought iron, or equivalent material, supported by bearing blocks, secured from moving by tiebacks installed at right angles and attached to a sound anchorage. Tiebacks be equivalent in strength to hoisting ropes. Repaired wire rope may not be used as suspension rope. Remember that vents, piping, and electrical conduits are not proper anchorage points. Wire ropes for suspension scaffolding. Wire suspension ropes may not be joined unless eye-splice thimbles and connected with shackles are used. The load end must be equipped with proper size thimbles and secured by eye splicing. Ropes must be inspected by a competent person prior to each work shift. Here to the right is an example of the wire rope eye splice. Wire rope inspection requirements. Wire rope should be replaced if there is physical damage that reduces strength, kinks that impair strength or operation, 6 randomly distributed broken wires in a rope lay, 3 broken wires in a strand of rope lay, abrasion, corrosion, or flattening that reduces the original diameter by 1/3 or more, evidence of heat damage, evidence that the secondary brake has been applied during an overspeed condition. Suspension scaffolding hoist requirements. Hoist must be tested by a qualified testing laboratory. Gasoline-powered equipment and hoists may not be used as suspension scaffolds. Gears and brakes of power-operated hoists must be enclosed. Suspension scaffolding hoists must have a secondary brake that engages in an emergency. The same equipment cannot be used for both hoisting and emergency use. Accessing and working on scaffolding. Accessing scaffolding systems. When scaffolds are greater than 2 feet above a point of access, ladders, stairways, ramps, or similar means must be used. Hook-on or attachable ladders must not tip the scaffold. The bottom rung of ladders or first step of ladders may be no more than 2 feet above the scaffold supporting level. Rest platforms required at 35-foot intervals. Slip-resistant tread required on all steps and landing. Never access scaffolding by climbing on cross beams like this gentleman pictured here. Proper use of scaffolding. Never overload your scaffolding. Do not use shore or lean-to scaffolds. Scaffolds and components must be inspected by a competent person before every work shift and after any event where the scaffolding may have been damaged. Scaffolds may not be moved horizontally while employees are on them. An OSHA case report. 6 Boilermakers had just left a suspension scaffold when it fell about 392 feet along with the foreman who was killed. The superintendent had ordered the scaffold's main support be disassembled before the scaffold was lowered to ground level. Rigging, welding machines, materials, and supplies, etc., were placed on the scaffold, and 2 1-inch wire rope hoist lines were cut free. This put the load on a single 3/4-inch wire rope hoist line, which was overloaded by 255%, and on the diesel hoist located outside the chimney, which was overloaded by 167%. Electrical clearance. Scaffolding must be kept clear of electrical lines at all times. Some insulated lines, voltage less than 300 volts, minimum distance away, 3 feet. 300 volts to 50 kilovolts, 10 feet. 50 kilovolts plus 10 feet plus 0.4 inches for every 1 kilovolt over 50 kilovolts. Non-insulated lines, voltage less than 50 kilovolts, 10 feet away, and more than 50 kilovolts, 10 feet plus 0.4 inches for every 1 kilovolt over 50 kilovolts away. I would just stay a long ways away from these lines because electricity can jump a long ways. Portable electrical tools. Metal scaffolding conducts electricity. Never forget that. An insulation failure in a power tool can electrify the whole structure. All portable electric equipment must be protected by a ground fault current interrupter, a GFCI, or a company-assured equipment grounding conductor program. Pictured here is a ground fault current interrupter, and it is a critical safety device. Working on scaffolds. Never work on scaffolding that is covered with ice, snow, or other slippery materials. That's just suicidal. Employees may not work on scaffolding during high winds or storms unless a competent person determines that it's safe anyway. Employees are protected by windscreens or fall arrest systems. Debris should not be allowed to accumulate on the platforms either. So if you're cutting and doing things like that up there, make sure your scraps get out of the way. Scaffolding should be kept clear of clutter. This scaffolding is full of trip hazards, as you can see. Working on scaffolds. Makeshift devices such as boxes and barrels cannot be used to increase working level height of employees. Ladders cannot be used on scaffolds unless it is a large area scaffold and the arrangement meets the requirements of 1926.451 F15I. The use of ladders on scaffolding is generally not allowed. Scaffolding fall protection requirements. Employees on a scaffold greater than 10 feet above a lower level must have fall protection. Employees on a scaffolding walkway must be protected by guardrails that have a minimum 200-pound top rail capacity, have a top rail height of 38 inches to 45 inches. Personal fall arrest systems used on scaffolds must be attached to a vertical lifeline, horizontal lifeline, or to a scaffold structure member. 1926.451 has special fall protection requirements for all types of scaffolding. Protection from falling objects. Not something you often think about when you're on a scaffold in a high place. Employees must wear hard hats. If there is a danger of falling objects from the scaffolding, the area below must be barricaded and employees prevented from entering. If employees need to access the areas beneath the scaffolding, tow boards, screens, and canopies must be used to protect employees from falling object hazards. What work behaviors lead to falling object hazards? And think about it. How can they be avoided? Specific scaffolding requirements. Pole scaffolding. A pole scaffold is a scaffold that is entirely made out of wood. When platforms are moved to the next level, the existing platform must remain undisturbed until new bearers have been set and braced. Pole scaffolds over 60 feet must be designed by a professional engineer. Diagonal bracing, the X-shaped supports, is required on both sides of double pole scaffolding and on the outside of single pole scaffolding. Tube and coupler scaffolds. These are supported or suspended scaffold consisting of platforms supported by tubing, erected with coupling devices, connecting uprights, braces, bearers, and runners. When platforms are moved to the next level, the existing platform must remain undisturbed until the new bearers have been set and braced. Couplers must be made of a structural steel. Gray cast iron is prohibited because it can shatter. Tube and coupler scaffolds over 125 feet must be designed by a professional engineer. Transverse bracing forming an X across the width of the scaffold must be installed at the scaffold end of every third set of posts. Fabricated frame scaffolds. These are scaffolds supported on fabricated end frames. When platforms are moved to the next level, the existing platform must remain undisturbed until new bearers have been set and braced. Fabricated frame scaffolds over 125 feet must be designed by a professional engineer. I don't know who wants to be up 125 feet on a scaffold. I certainly don't. Fabricated frame scaffolds should only be used to support workers unless specifically designed to bear loads and prevent tipping. A carpenter's bracket scaffold. Each bracket must be connected to the supporting structure by nails, a metal stud attachment device, or welding. Folding-type metal brackets, when extended for use, must be bolted or secured with a locking pin. Outrigger scaffolding. An outrigger scaffold is one with a platform resting on outrigger beams that extend out beyond the wall or structure. Outrigger beams must be secured against movement and must be braced at the fulcrum point to prevent tipping. Inboard ends of outrigger beams must be anchored by braced struts in contact with overhead beams or the ceiling or secured to the floor. Outrigger scaffolds must be designed by a professional engineer. The inboard beams must be at least 1.5 times the length of the outboard beams. Pump jack scaffolding. A pump jack scaffold is a platform supported by vertical poles and movable support brackets. Must be fabricated from metal plates and angles and have 2 positive gripping mechanisms. Poles must be secured to the structure by rigid triangular bracing like you see in the picture. Pump jack scaffolding is common because it is easy to adjust the working height. Ladder jack scaffolding is also adjustable. A ladder jack scaffold is made by resting a working platform on brackets attached to a ladder, or 2 ladders in this case. A platform may not exceed a 20-foot height. The ladders must be placed, fastened, or equipped to prevent slippage. The weight from the platform must bear on the side rails and ladder rungs, or ladder rungs alone. Ladder jack scaffolds should be used for light work only. The ladders must be compliant with Subpart X, stairways, and ladders. So as you can see, there is some crossover between ladders and scaffolding. Single-point adjustable scaffolding. Single-point adjustable scaffolding is one that is suspended from a single rope and has adjustable height. The support rope must be vertical unless the rigging is designed by a qualified person and meets the requirements of 1926.452. The maximum intended load for single-point adjustable scaffolding is 250 pounds. That's you and anything else you have on it. Window washers commonly use this type of scaffolding. 2-point adjustable scaffolding, also known as swing stage scaffolds. These scaffolds are suspended from 2 ropes. Workers on these scaffolds must be protected by both guardrails and personal fall arrest systems. Platforms on this type should not be wider than 36 inches. Multi-level suspended scaffolds must have additional independent support lines that are equal in number to the points supported, equal in strength to the suspension ropes, rigged to support the scaffold if the suspension ropes fail. Independent support lines and suspension ropes may not be connected to the same anchorage. Support for platforms must be attached directly to support stirrups and not other platforms. Mobile scaffolding, which many people are familiar with. Mobile scaffolds must be plumb, level, and squared, must be braced with cross, horizontal, and diagonal braces to support vertical members and prevent collapse. To prevent moving, wheels must be locked. Platforms may not extend beyond the base supports. Moving mobile scaffolding must be stabilized to prevent tipping during movement. Power systems used to move scaffolding must be designed for that purpose. Employees may not ride on scaffolds while moved unless they are made aware of the move and the scaffold meets the requirements of 1926.452. So I guess if you hold on really good and you're aware it's moving, it's okay. When moving, the force used to move should be applied as close to the base as possible. In summary, scaffolding systems must be designed by a qualified person. Scaffolding must be able to support its weight and 4 times the max load. Stall load on hoist for adjustable scaffolding must not exceed 3 times the rated load. Employees working on scaffolding above 10 feet require fall protection too. Portable electrical equipment must have GFCIs, protected by a ground fault circuit interrupt. This concludes this final safety training section for this month's safety training. We covered 4 key areas: LOTO or Lockout Tagout, electrical GFCI, and assured grounding, confined space, PCRS, and ladders and scaffolding. As your instructor, I do sincerely hope you enjoyed this video. In closing, if I could ask you to do everyone at Basin Safety a favor for working so hard to put this training together for you, could you take out your smartphone, find Basin Safety on Google? The page looks exactly like this, and kindly rate the training that you received here today. Please mention Basin Safety in your review comments, as it does help others find similar quality content. As you will see when you get to our review page, many others ahead of you have rated us at the top level with 5 stars. That doesn't mean we are perfect because nobody is, but it simply means we met your expectations for training today. I'm not going to expect to see the words lockout, tagout, electrical GFCI and assured grounding, confined space, and ladders and scaffolding in your review, but that would certainly be a bonus and much appreciated. I'm Kevin Hunter, and I thank you so much for watching this month's safety training presentation from Basin Academy. Till next time, be sharp, be safe, and take care. I expect to see you next month.